Hey guys, welcome to my channel iCode. I am Pallav and on this channel I upload videos related to iOS programming every Sunday. And today it's about improving the debugging skills. I agree that as an iOS developer, it's really important to have in-depth knowledge of Swift, grip over the frameworks like Foundation, UIKit, Swift UI, etc. But at the same time, it's even more important to have good debugging skills. Because we invest a significant amount of time in bug fixes, performance improvement, and all these require really good debugging skills. So today in this video, we will look at different use cases and we'll try to explore different ways of debugging through them. We will be looking at all these debugging skills, and the first one is breakpoints. So we'll see different types of breakpoints, not just the conventional, the user-defined breakpoints, but the other breakpoints that are available to us. And then we'll see the LLDB, so how to use it efficiently, the low-level debugger, the commands like PO, PV. And then we'll see that how to look into the container of the device. So for certain bugs, we need to look into the device's container. So we'll see that how can we do that. And then we will see the network link conditioner. So for some specific kind of bugs that are only replicated in the bad network scenarios, we need to replicate the bad network scenario. So for that, we will see that what is network link conditioner and how can we use it. And then we will be identifying the issues which occur only on device and not in debug mode. At last, we will see view hierarchy. Along the way, I'll be giving some extra piece of useful information. So for example, while looking at view hierarchy, I'll tell you that how can we print entire view hierarchy without using any external tool. So you might consider watching complete video. Let's dive in. So let's start with the breakpoints. Breakpoints is one of those debugging ways which is exhaustively used by developers, and it is very easy to use. So what breakpoint does is it halts the control, it stops the control at a specific point, and then we can inspect the values of the variable which are available at that scope. So the first and the easiest one is the user-defined breakpoint. So let's say if I write where a is equal to 10 and where b is equal to 20, and if I put a print statement here saying a plus b. But at this point in time, I want to check that what is the value of a and b. What I can do is I can simply put a breakpoint here by just clicking onto the gutter, and then I can give it a run. Once it will run, the control will stop at line number 17 where the breakpoint is there, and then we can inspect the values of the variables which are available in the scope. So here I can see, I can just hover on the variable and it will print the value. So say 10 and b is 20. So this is one of the easiest and the most widely used ways of using the breakpoints. So breakpoints can do a lot more than this. There are other types of breakpoints. So if we click here on the breakpoints tab, there's a small plus button here. If we click on this, we get to see that there's Swift error breakpoint, exception breakpoints, and symbolic breakpoints, and few other types of breakpoints. So if we put an exception breakpoint, it will halt the control, it will stop the control as soon as the crash is encountered. So it is of great use. The other one is Swift error breakpoint. So let's try and use Swift error breakpoint. It basically stops the control at the point from where the Swift error is thrown. So you can imagine that in a large project where you are having a chain of methods calling each other, let's say method A calls method B calls method C calls method D, and method D throws an error which is passed all the way back to method A. Now we want to identify that what is the origin of the error, which method is actually throwing the error. Though it is being handled back at the method A, but you want to identify that what is the root cause from which method the error is actually being thrown. Now this can be done very easily using Swift error breakpoint. So let's see this. I'm having a saved code snippet, so we'll just use it. Here in the view did load, method C is being called, method C calls method B, B calls A, and from A we are throwing an error. Though this error is being handled at the top in view did load, but let's try to identify that what is the root cause, which method is actually throwing the error, whether it's B, it's C, or it's A. So with Swift error breakpoints enabled, if we run this, let's see that where does the control stops. The control is stopped at line number 32, which is the root cause, which is the culprit. So method A, and specifically this line number 32, is throwing the error. So control is stopped here. And we just saw that how easy it is to identify that exactly at what point the error is being thrown. So in the breakpoints we saw the user-defined breakpoints, the conventional ones which are just enabled by clicking onto the gutter. They can be used for inspecting the values of the variables available in that scope. And then the exception breakpoint, so we can use it for identifying the point from where the crash is occurring. Then the third one, the swift error breakpoint, this can be used to identify the point from where the error is being thrown. No matter how deep is the chain, swift error breakpoint just works like a charm. And do you know that you can actually share the breakpoints? So if I just put a breakpoint here and here, I can actually share this with my teammate. Next time when you are guiding your teammate while debugging an issue, that put a breakpoint at line number 212, put a breakpoint at line number 103. Rather, you can try sharing the breakpoints. So they are tracked by Git exactly like your source code. So if your teammate removes the breakpoint and then you take the pull, the breakpoint on your copy will also be removed. So that's the thing that needs to be taken care, but you can share the breakpoints. It can be of use sometimes. Let's see the second way of debugging, that is LLDB. LLDB or low level debugger is another great way of debugging, and I'm sure that you guys would have used PO for printing the description of the variables. But here what I want to focus on is that PO is far more useful than just printing the statements. It can be actually used to execute the commands, to execute the statements. It works just like your source code is being compiled and executed. So in the same way, LLDB actually generates the source code from your PO commands, compile it with the embedded Swift, and clang compiler before executing it. So let's see this by a use case. I'm having a struct employee, so we'll just use it here. So here we are having nothing much, just ID, name, joining date, and is eligible for a gratuity. So it's boot, and I have mentioned this here for a purpose that we'll see in a minute. But before that, let's create an object of this. So say where employee is equal to employee and ID1, name say John, joining date say today's date, and is eligible for gratuity say false. Print employee.name. Now I'll just put a breakpoint here so that we can play with the LLDB commands, the POP and the V, and we'll give it a run. Now using PO command, we can obviously print the description of the object. So if I go for PO employee, we get the description of the employee. But apart from this, what we can do is we can actually execute the statements using PO. So if I try PO employee dot joining date is greater than date. So here this statement has been executed, and this way we can actually make some use of it in certain scenarios. We need to execute something on the runtime to check certain things. So PO can be of use there. And now let's see the P command. So P can also print the description of the objects. But when the same thing was being done by PO, what is the use of P? So let's say that if I want to change the value of a variable at runtime, I can do that using P. So P is just an alias of expr, so you can also try the expr thing, but I prefer P. And to see P in action, let's change this print statement. So let's first stop this, and instead of this, let's put it like print is eligible, employee.is eligible for gratuity. Let's use ternary here, and if it is eligible for gratuity, let's print that eligible, and if not, let's print not eligible. And now let's give it a run. So here we'll try changing the value of this variable is eligible for gratuity. Let's first test that what is its current value. So P employee dot is eligible for gratuity, and it's false. And now let's try changing it. So if I go for P employee dot is eligible for gratuity is equal to true, and now if I try printing it, we are actually getting true. So is this just for this LLDB console, or the value has actually been changed? So that we can confirm by continuing the execution, and we see that our print statement prints the eligible, which means that we have actually changed the value of this variable is eligible for gratuity. So this way you can test a lot of scenarios where you need to change the value of variable. So let's say that you are fetching the response from API, and in the response there's some variable whose value is false, but you wanted to test the flows for which the value should have been true. So you can very easily do that. Just put a breakpoint and just change the value. That's all. So till now we saw that okay, PU can be used for printing the description of the variables, P can be used for the same as well as for changing the values of the variables at runtime, and this is fine. But then what is the need of the third command V? Why is V used for? So to understand it, let's introduce a little complexity here. So instead of this struct employee, let's just change this to say software developer, and let's make a protocol employee to which this software developer confirms. And instead of making the object of employee, let's make the object of software developer John and false, and let's explicitly mention the type as employee. No need of this print statement here, so we'll just put a print saying let's test, and let's put a breakpoint over here. So now we'll see that what is the limitation of PO and P, and then we'll understand that why is it so. So let's first run it, and now if I want to see that what is the name of the employee using the PO command, if I go for PO employee dot name, employee has no member name. If I try P here, P employee, my bad, the lowercase p employee dot name, the same error. But if I try V employee dot name, I'm getting the name John. So what is different between V and P? Let's try and understand that. PO and P didn't work because they compute the dynamic types in the result, while V does not compile your expressions at all. It just prints the values available in the stack frame. So here the static type that we gave was employee, and employee does not know that what is name, joining date, or is eligible for gratuity. That's why PO and P didn't work, while we took the values from the stack frame and hence it was knowing employee name. So when I say that V does not compile your statements, we can actually confirm it by writing V employee dot name dot say uppercase. This does not work because V is not compiling the statement. This is not being executed again, what PO and P used to do. So there are some upside and downsides of both. If we go for using PO or P here, we could have used employee.name.uppercase. So we know the pros and cons both of PO, P and V, and we can actually use them very efficiently while our debugging. Now let's see network link conditioners. Now comes those issues which occur only in low network or bad network scenarios. And in order to fix them, we need to replicate the bad network scenario. And to do so, Apple has provided a tool called Network Link Conditioner. It is available for both device and simulator. So let's see it. This can be downloaded from developer.apple.com. I'll put the link in the description. Once you download it from there, you will get this directory hardware. And inside hardware, there will be this network link conditioner. So just double click it and install it. Once you install this network link conditioner, you will see something like this. So let's test that how this network link conditioner works. So I'll just hit this fast.com here to get my internet speed, that what is it coming now. So it is somewhere around 50 Mbps. And now what I'll do is that I will turn on the network link conditioner. So I'll just go to the system preferences, and here it is having this network link conditioner that I just installed. So I click on it and I'll turn it to say 100% loss, and I'll turn the network link conditioner on. Now if I reload, I'm getting the speed as 0, and we can even change the profile. So if we go back to the network link conditioner, and I can change this from 100% loss to 3G. So in 3G, maybe I'll get some speed, not as good as my Wi-Fi speed, but because I intentionally want my speed to be low for replicating those scenarios which occur in bad networks. So if I put this on 3G and if I refresh this, so I'll get some speed, maybe around 100, 200 kbps, 500 kbps, but not as good as Wi-Fi. So we can toggle this, we can create our own profile, and we can control the bandwidth, latency, the packet loss, and everything. So this can be done, and because our simulator uses the same internet connection as that of our MacBook, so this will control the network speed, and we can use this on the device also. So for enabling it on device, what we need to do is go to the settings. In the settings you will find the developer section. Go to the developer section and you will find network link conditioner over there. Just toggle the enable and disable mode of the network link conditioner and then we can use it. So if I go for testing the speed on device, if I hit the fast.com without network link conditioner enabled, I'm getting the good speed near about 20 Mbps, 30 Mbps. But now if I turn the network link conditioner on with 100% loss, I'll get the 0 kbps as we saw. And then if I change the profile, then if I change the mode to maybe 3G, then probably I'll get the speed somewhere around 100 kbps, 500 kbps. But that's enough for simulating the bad network scenarios to replicate our issues. So it's a great tool for debugging such issues, such scenarios. Now let's discuss another way of debugging, what I call it as looking into the container of the device. So for this, assume a use case that you are working on a project which is having the involvement of database in it. For now we will consider the SQLite database, but it can be any other database. Here you need to verify that whether your records are getting inserted in the database or not. For this, I'm having this file database helper. There's nothing much in it. It just opens a DB and just creates a table. So we are creating a table for employees. It is having just name and designation of the employee. And then there's this method insert, through which we'll try to insert our records. So let's try and do that. I'm having this instance of database helper over here. And here what I'll do is I'll just use this database helper dot insert, and we'll insert a record, say John, and designation is say software developer. So I'll give it a run, and in the insert method I have put the log saying that record inserted successfully. So if it does, it should print that statement, but again we will verify it. So successfully inserted row. So that is our confirmation that the record has been inserted. But now in certain scenarios some issues might happen, and for which we need to look into the container. This is not specific for looking into a database, but this is a technique that you can use for looking into the device container. So maybe confirming that whether the file has been downloaded or not, or maybe the images that you are caching, the caching has been done properly or not. So it's a way that you can use in various scenarios. So I'll use this tool SimSim, and using this we'll go to our application debugging, and in the finder. So basically this directory, this folder is the container where all the data, all our document directory for this particular application is stored. So let's go here and verify. Here's our database that we created, employees.db, and if I open this using SQLite browser, and if I go for browsing the data, our record should be there. John software developer, the data that we inserted is here. So this is one of the ways through which you can look into the container, and this is pretty straightforward on the simulator, but if you're running on device, then it is not that straightforward. So let's look at the way that how can we get the container when we are running our application on the actual device instead of a simulator. For downloading the container on device, click on Windows and then select device and simulator. There you will find your application. Click on it, and below that there's a small settings button. Click on the settings button. There we'll have an option for downloading the container. So click on it and download the container. This container will be exactly same as we downloaded for the simulator. So just download it. This is how it will look like. It will be XE app data. So right clicking on it, and if we click on show package content, we'll get the directory. Here in the app data, we'll get our employees DB, same as we got for the simulator. So again we can click on this and we can explore the database in the SQLite browser, or we can view the files downloaded or the images cached. Whatever we wanted to do with our container, we can do for the device too. And the way for downloading the container on the device is easy. Just go to Windows, Devices and Simulator, select your app and click on the settings button for downloading the container. As simple as that. Now let's discuss about even more complex problem. So at times we encounter such issues which are not replicated on the simulator. They occur only on device, and that too only in the release mode, or what we can say that they do not occur in the debug mode. So if you directly run your application from the Xcode, the issue won't replicate. If you have not encountered any such issue, lucky you, but sometime in your developer career you might encounter such issue, and then this debug technique will help you. So I experienced one of such issues recently. If you download a video, which is HLS stream, technically M3 UAT file. So if you download a HLS stream using AV asset download task, it does not download on the simulators. For that, you will have to use device. And even more complex is that if you try to get the functionalities like storing the progress, that is the partial downloads. So assume that you are downloading a content, you pause it, and then you kill the app. And on relaunch, if you want to continue it from the point you left, you will have to store the progress. This cannot be done in the debug mode. So Apple has not mentioned this in the documentation, but I faced this problem. So the two conditions here are that first, you cannot download it on the simulator, and the second one is that the resuming of the progress, resuming of the download from the point where it was left cannot happen in the debug mode. So if I run the application directly from the Xcode, it won't work. In this case, if some issue occurs, what's the way for debugging it? So a workaround that I thought of is creating a log file. Because we know that the container of our application can be downloaded from the device, so what if we place a log file there and put the necessary logs over there? Once we encounter the issue, we can get the log file from the downloaded container and can inspect it that what all logs have been printed and from where did the printing of the logs stop. That will give us a fair idea of how to debug issues like this. Now the only point is that how to create a log file, and that's a piece of cake. So let's look at it. For that, I'm having this saved code snippet create log file. So it's just a function where we are getting the path of the document directory, giving a file name. So I've just used date over here. It's just file name, and then we are opening the file in the append mode. So let's do one thing. Let's put a log here. And one thing that you need to take care of, that print won't be treated as log here. So for creating or saving the logs in the log file, we'll have to use nslog. So if I put nslog here, first log, and then some piece of code. So nothing much. Let's say where a is equal to 10, or anything that we wanted to do, and then maybe nslog second log. If I give it a run, my bad, I haven't called this function. So let's first call this function that create log file. And now if I give it a run, so our document directory should have the file that we created, and it should have these logs, first log and second log. So let's try exploring our container using SimSim. So debugging one finder, and here's the file that we just created. So if I just view it, first log and second log. So this is a workaround. This is a kind of way that we can use for identifying the issues which do not occur on the simulators or which do not occur in the debug mode. What you can do is you can just create a log file, put some logs in it, and then later can go through them to have a fair idea that what went wrong. The last part of this video, using view hierarchy for debugging UI related issues. Looking at the view hierarchy gives us a clear picture that which view is placed over which view. So if we face the issues like that view is not visible or partially visible, we can go to the view hierarchy and can solve these issues pretty easily. So here I'm having this application. This is just for showing the view hierarchy, so it has nothing much but just a list of movies. So if I want to view the view hierarchy here, all I need to do is just click on this button here, and this will open the view hierarchy, which will give me a clear picture that how is the placement of the views, which view is covering which view, and we can even rotate it to have a three-dimensional view. This will give us an idea that which view is beneath which view, and we can even look at the frames. So if we go here we can select the view and can look at the frame, that actually what is the frame. So 187.55 and 137, this is the frame of this particular view. We can look at this hierarchy, that how it goes, which view is falling under which view. If we explore this, the entire hierarchy is visible. So this is a great tool for debugging the UI related issues. And one thing that I said in the starting of this video, that we can print entire view hierarchy without using any external tool. So let's try that how can we do that. So I'll just resume it here, and I'll put a breakpoint here in the did select, so just that I can use the PO here, and PO self dot view dot value for key, and the key is recursive description. So if I hit enter here, you can see that entire view hierarchy that we are having, that we saw in the debug view hierarchy section, we actually get it here. So it gives us even more clear picture that exactly what is the frame of which view is falling under which view, so parent, child, and the entire hierarchy with all the description printed here. So even this can be useful at times. We can use all these techniques to debug the UI issues, and it helps a lot. So this was pretty much for this video. A new video comes out every Sunday, so stay tuned and stay safe. Let's write better code together. Happy coding.